On the morning of August 26th, a wall of water and mud surged out of the Himalayas into Nepal's Rasuwa district. It tore down the Bhote Koshi river system and pushed on toward the Trishuli. Homes were destroyed. Hydropower sites were wrecked. The strange part was the weather. Officials said the sun was out. No heavy rain had fallen over the valleys that flooded. So, where did all that water come from? The leading explanation begins high on the Nepal-China frontier, about 20 kilometers northeast of the Rajawagadi border crossing. Preliminary satellite analysis points to a sudden collapse of ice and rock. Researchers at the International Center for Integrated Mountain Development believe that Avalanche dropped into the Lhende, a small tributary of the Bhote Koshi. They stress that this remains a preliminary assessment rather than a settled conclusion. An avalanche by itself does not explain a flood this violent. The suspected sequence is a cascade. First, a huge mass of ice and shattered rock falls into a narrow river channel. That impact alone displaces water. The debris can then jam the valley and form a temporary natural dam. Water piles up behind the blockage until the dam gives way and releases everything at once. That release grows more destructive as it travels downhill. Fast water strips sediment from the banks and the riverbed. It gathers boulders and trees and wreckage. The flow becomes far denser than ordinary floodwater and starts to behave like moving wet concrete. A steep valley concentrates the force and keeps it accelerating. The measurements show how extreme the wave was. On the Trishuli at Galchi, the water rose by as much as 9 meters in half an hour. At Maleku, it climbed about 7 meters in a similar window. Several monitoring stations were damaged or swept away entirely. The emergency became harder to track at the moment tracking mattered most. Geography then multiplied the damage. In these valleys, roads and bridges and settlements all crowd onto thin strips of flat ground beside the river. Hydropower projects sit directly in the channel. When a river turns into a debris surge, those corridors become the path of destruction. Rescue crews face steep terrain with roads and power and communications cut. There is also an earthquake question. A magnitude 4.4 quake was recorded shortly before the flood, and nearby seismic stations picked up unusual signals. Shaking could plausibly have loosened the slope. But timing is not proof. Scientists are still testing whether those signals are physically connected to the avalanche. For now, blaming the earthquake would run ahead of the evidence. What about climate change? Across the Hindu Kush Himalaya, warming is reshaping glaciers and snow and permafrost, and it is destabilizing mountain slopes. That raises the background risk of ice avalanches and glacial floods. Even so, it is too early to assign this particular disaster a climate share. The honest position is that regional hazard is rising while attribution for this event still needs more data. This valley has now flooded twice in 14 months. That pattern makes it more than a freak accident. It is a transboundary warning. The suspected source sat inside Tibet, the destruction landed in Nepal, and the alerts traveled far downstream. No single district can watch that whole chain by itself. The immediate priorities are rescue, dependable warnings, and checking whether unstable debris still sits upstream. The wider lesson is that mountain disasters arrive as linked events. A collapse becomes a dam. A dam becomes a flood wave. Within hours, a remote failure in the ice reaches homes and roads far below. The suspected trigger is an ice and rock avalanche. The exact sequence is still under investigation. In a disaster this fresh, saying so plainly is part of telling the truth.